Just to give some background on me, I actually started life many, many years ago as a COBOL programmer on mainframes. There aren't many of us left, I think. And I could probably earn more money by being one again because they're in short supply. So I sort of kind of seen the evolution of technology from mainframes to mini computers through Unix to Wintel, Intel, and now the wonderful world of cloud. I've actually been working with SAP since 2002, so this is my kind of 18th year of involvement, and that at that time primarily focused on hardware infrastructure sort of design for SAP rather than being an SAP sort of software guru. And that started when I worked for Sun, because back in 2002, Sun had the biggest Unix servers on the planet, long since eclipsed by IBM. But back then they had 60, it seems small now, 64 processors and 64 gig of memory. And they used to cost about $2.5 million a time for those boxes. You can probably get more out of a $5,000 Intel server today than you got out of those boxes all those years ago. I moved into the sort of the virtualization of SAP back in 2011 when I joined a startup called VCE, which is a VMware Cisco EMC joint venture. So very much focused on what was called converged infrastructure. So you bought one of these boxes and it turned up on your doorstep pre-configured with VMware running, ready for you to start provisioning your virtual machines. And what they were looking for was somebody who understood about SAP and how that would work in a virtual environment. And after a few years of doing that, I could see the future lay actually in hyperscale public cloud, and was lucky enough to join Microsoft back in June 2017. And at that time, I was the first UK dedicated resource for SAP. There's a couple of colleagues who were actually based in the UK and had joined, but they were strictly global resources. The first one was a guy called Chandu Chiti, who some of you may have come across. His role was actually global. He just happened to be based here. What I hope to do today is just give you some of the learnings I've kind of picked up over those sort of 3.5 years since I joined. SAP on Azure has matured hugely in that time. And if I remember, I will try and touch on some of the things that have kind of come along during that time. And one of my, I can't remember what the next slide shows. Oh yeah. So one of my kind of comments is, one of the challenges with bringing SAP into Azure is that SAP is not by any stretch of imagination, a cloud native application. It's essentially been around for over 40 years now. Started on mainframes, moved into the world of Unix in 1993, 94. But the technical architecture really hasn't changed that much, certainly not since that 1993. And now they kind of claim to have, that the new applications are sort of built for the cloud, only in the minds of the people who built them. So they're not inherently cloud friendly. So there's no sort of ability to sort of auto scale anything because everything is stateful, not stateless. And so if you want to kind of expand the application tier, yes, you can add an application server, but can you take it away easily? Answer, no. So the kind of things like VM scale sets, which are lovely for sort of web applications and proper cloud native applications, to just expand and contract as the workload kind of goes up and down. We just can't leverage any of that in the SAP world today. And I have no idea if we ever will, really. First level setting, a lot of people think SAP and HANA in the same breath. HANA is an in-memory database that they first released in 2011. And they'd already been going for 35 years by then. But it's the kind of thing that they've become most famous for. But to give SAP its real name, the clue is in the title. And the real important one is that word applications. So it's really their core business has always been applications, not databases. They came up with this idea that with cheap commodity hardware now having large memory capability, why do you why do you run a database from disk when you could stick the whole database into memory? And conceptually, it's good. The problem is, if you actually look at the real costs, memory is between 10 and 20 times as expensive per terabyte as disk, which begs the question, if I put data into memory that I don't need to be there, it's a very expensive way of storing data. The name, as I say, SAP comes from that systems, applications and products in data processing, or more accurately, the one I'm not going to pronounce at the bottom, which is the German language version of it. It's rather convenient, actually, but SAP is still SAP in German as well, or vice versa. It translates nicely. So the applications is really where their core business is and remains. And I kind of stress that because if you look at most companies' websites, so if you're looking at cloud providers or traditional hardware vendors like Dell and HP and IBM, you would think the whole world was dominated by HANA today. It really isn't. So when it comes to migrating, this is a marketing slide, and I apologize, but I just wanted to use it. So this is kind of what Microsoft will position as what a customer running SAP today could do in terms of migrating to Azure. And the big theory is everybody should ultimately move from the left to the right. And that the future for the world is for all SAP customers will run the latest version of their software called S/4HANA. And, that's the target. Now, until about 18 months ago, the official line from SAP was that beyond 2025, only S/4HANA would be supported. So that was driving a lot of customers to sort of go, oh, we really need to sort of think about moving to this S/4HANA thing. We need to do it fairly quickly. Then, as I say, about 18 months ago, maybe 24 now, they strangely announced that date had moved to 2030. So the pressure to move to S/4HANA, and hence really to HANA as a database, has been pushed back. So if I look at what we spend most of our time on, in reality, it's that bit up in the kind of top left-hand corner. So it's customers who are running SAP today. They're looking to re-platform their SAP, but they don't really want to do much else. They just want to take largely what they have today and move it onto a new platform. And there's lots of reasons customers do it. The most common really is, or one of the most common triggers is there's either a hardware refresh or a data center outsource contract that's coming up for renewal. People go, right, do we just buy some new hardware, stick it in a new data center somewhere, or do we use this as the opportunity to do something a bit different and move to cloud? And that's really, I would say, where 90% of our work, maybe even more than 90%, is today. Some people will look at HANA as part of that, and they may move, an application or two onto HANA, partly just to get some exposure and experience of HANA. But equally, a lot just simply lift and shift what they have. So forget the marketing, forget if you go to probably Microsoft.com/SAP, you'll find us talking an awful lot about HANA. That's not the bulk of what we are dealing with today for most customers. Again, a bit of a marketing slide, but important if you've got SAP, is what runs in Azure. So what you've got is SAP has a whole range of applications. They're all those little, let me just laser pointer. So you get all these applications up here. They're all typically abbreviated to 3 or 2 letters, ECC, SRM, etc. And then they run on one of a number of databases. And when on that previous slide, I used the expression NEDB. That really means anything but HANA. So it's a generic term to mean SQL, SAP ASE, Oracle, etc. And it's just a shorthand way that SAP tend to refer to these databases. And we can run on Windows or Linux on Azure, and then we certify certain VM types and storage and other things to run SAP. So not everything is supported. You also find some little anomalies. So, for example, if you want to run Oracle database on Linux, the only supported combination in Azure for SAP is to run it on Oracle Linux. No technical limitation, just a restriction that SAP put in. So it's important to realize this. So we've have customers who were running Oracle on Red Hat on-prem, and Nick knows one quite well, who were forced effectively to move to Oracle Linux or the SAP estate, because that's all that Oracle allowed them to do. The hidden message there is, if you want to run SAP on Oracle database in Oracle Cloud, the only supported Linux is Oracle Linux today. So they don't want to give anybody else a benefit of being able to run on other flavors of Linux. So pure marketing restriction. Again, people who know SAP and are familiar with SAP support notes, there is this wonderful note 1928533. That is the kind of the key note that tells you all about what is supported in Azure. I think we're on to version something like about 119. It probably gets versioned roughly once a month as we add new certifications, tweak. Some of them are significant, some of them minor tweaks. But if you're looking at SAP on Azure, that's the place to go. It does reference some other notes that talk about specifics, like, for example, around what's supported in the Oracle world, because it has its own little note, because there's quite a lot of nuances, again, about what you can and can't do. But that's the sort of key one. So we can support most things. Importantly, and the good folk on here probably are well aware of this, you cannot run AIX, HP Unix, or Solaris in Azure. There's sometimes we come across people who still think you can, because that's what they're running their SAP estate on-prem today. But no, you can't. It's going to move. And most typically, we will migrate those to Linux. You can go to Windows. It's more unusual. And the primary reason behind that is a lot of people will have many interfaces talking to SAP, either taking data from other apps into SAP or out of SAP into other applications. And at least some of those will often involve really basic level, kind of create a file, run a script. The script looks for the file, picks it up, moves it somewhere, runs another job to ingest it into another system, whatever. And it's just easier to move those. One of the things that, and I should have put a slide in and I kind of forgot, I just realized, was with migrating, particularly for those customers who are not running on Windows and Linux today, there are standard SAP tools to migrate and change both the operating system and the database. So if you are running, for example, Oracle on AIX, and we have quite a few customers who are doing that, and also DB2 on AIX, looking to move to Azure, there are standard migration tools from SAP to migrate those workloads. Basically, in very simple terms, they unpack the whole database into flat files. You copy them across and you re-ingest them on the other side. The nice thing about that is you can change the OS or the database or both. So there is an element that for people coming off those sort of traditional Unix platforms, it can also be a good opportunity to look at changing the database. So we do have customers who are looking to get out of some of their traditional contractual arrangements around particularly around both Oracle and DB2, and have used a migration to Azure as a trigger to not only change, say, from AIX, which is the most common one we see, to Linux or Windows, but change the database. And possibly even more surprisingly to some people, that includes going to things like SQL Server on Windows. I think if you said 10 years ago that people would move from an Oracle on a Unix platform to Windows SQL to run a mission critical application like SAP, people would have collapsed in fits of laughter. But 10 years is a long time in IT, and in that 10 years, the maturity of both Windows Server and SQL has gone up hugely, and it can now be a very cost-effective way of running SAP in Azure. And we have customers that have done that, quite a number, in fact. So we can change. When it comes to running, and I thought how to present this a bit differently. So these are, as I said, we certify particular virtual machines to run SAP. And we go, and SAP measures compute performance in these things called SAP, which are SAP Application Performance Standard. And what they did was they created a benchmark which would effectively validate the performance of different platforms. And it was designed really in days when there were multiple Unix platforms, different processor architectures from IBM Power to Sun Spark to HP PA RISC and then Itanium. And there was no easy way to compare performance. So it's a true application benchmark. It actually uses their core application and it uses a simulated workload. And what you'll notice when you look at this is down at the bottom end here, we have lots of virtual machines very closely together. As you increase the CPU counts, the SAPs go up, but the intervals between the VMs starts to get wider and wider until we end up with these very big chunks. And the reason I say that is, again, kind of lessons learned. Most customers are going to be in this bottom corner here, up to around about sort of 100,000 SAPs. And in there, we've got very fine-grained virtual machines. Still a few biggish gaps. And I did actually leave. No, I didn't. I thought I left a couple of lines out. I didn't know. That was on a later slide. But getting the sizing of particularly the database, spot on is really important, because the database servers will typically prove to be 80 to 90%, and if it's HANA, probably 95% of where your Azure IaaS. So being on the wrong size VM for your database is costly. And it's not only costly in terms of VM price, but it's costly in terms potentially of database license charges. So what happens is a lot of people today do a number of things. One is sometimes they run other workloads on the database server, and I'll come to that a bit later. The other thing is they're a bit sloppy. They're running it on a system which is really too big, but there's nothing usefully to do with that system other than leave that database running on it. And there's a tendency to try and sort of just size like for like, but really drilling down into what's going on those database servers. Are they really being utilized? Sometimes when we look at real utilization, you find people are peaking at sort of 25, 30% of the available CPU and memory. And you go, I think that system's massively oversized. And even more, you can drill into with Oracle, because I've been doing a lot of this recently, looking at I forgot what they call it, AWR reports, which is I forgot what they stand for. It's the Oracle's analysis of the workload of the database server. And when you drill into that, not me personally, we have some Oracle experts who do it, luckily, you can often find, there are bottlenecks which have nothing to do with compute and memory. They're sort of storage I/O bottlenecks as an example. So the customer thinks that the VM is kind of a bottleneck, but it's actually the storage that's the bottleneck, I believe it. Or you're seeing an awful lot of I/O being generated, and you notice that actually it's sitting on a machine that doesn't have a huge amount of memory. Moving Oracle to a new machine with a lot more memory allows you to increase the effectively the memory that's used to cache data, and that way it will perform a lot better. So there's all sorts of nuances to get kind of what you're trying to do is push these VMs down as small as you can get away with in Azure to bring down the VM cost and to bring down the any resulting database license costs. But the important thing is this, when I talked about that 64 CPU box 18 years ago, that had, each of those CPUs gave you 147 SAPs. So that was less than 10,000 SAPs. It cost $2.5 million, and it sits somewhere in that smallest little blob down at the bottom there. So the fact we now do 488,000 is quite a big number. The largest Unix box you can buy today even delivers just over, I think it's about 1.1 million SAPs. I've never met anybody who uses all of that for any one workload. And I'm getting an echo. Is anybody else getting an echo?
It could be me. I'll go on mute. Sorry, Nick.
Okay. As virtual machines, an example of something which we introduced for the benefit of the SAP was about a year, 18 months ago now, was these things called proximity placement groups. The idea with a proximity placement group is it allows you to ensure that when you create, and again, when I said that SAP is not inherently a cloud native application, it is very sensitive to network latency between the application tier and the database tier. And you may not be aware of this, but when you provision virtual machines in Azure, they don't necessarily end up even in the same data center. And if you're in a region that has zones, which is many of them now, so UK South, Europe West and North, they won't even necessarily be in the same zone, because if you don't explicitly deploy things in zones, Azure can just position the VM any way it likes. So your app and your database could end up being in a different data center and in fact in a different zone. Now, it doesn't matter. Some regions it's less of an issue than others because the zones are quite close, but equally some regions, and Europe West is a really good example, the most distant zone is significantly away from the other two zones in Amsterdam. And that we found was causing performance issues if by chance the DB and the apps got deployed in different zones. So if you create an availability set, but you're not using zones, your VMs can end up anywhere within that region. So proximity placement groups introduced, you can use them for other apps if you've got other apps that are sensitive to network latency, but it's a particular problem with SAP. Storage, we're very restricted, again, back to that SAP note, that 1928533. We only really support, if you just assume, we support managed disks for running SAP workloads. If you've got older systems and you're an early adopter, you could be running on classic, not managed disks. But if you're provisioning anything today, and we use, we can support, standard HDD, SSD, premium SSD, and Ultra. By far and away, the majority of workloads, SAP workloads, will use premium SSD for production. We rarely need Ultra disk, and anybody who's kind of looked at them will know they're quite expensive. There are specific use cases where they can be valuable, particularly for very high throughput database log files, where you've kind of got two choices. You either kind of grab a bunch of premium SSDs and strike them together to get high throughput, or when you start doing that and look at the cost, then suddenly an Ultra disk can possibly give you the IOPS and the throughput quite cost effectively compared to multiple premium SSDs. And then a lot of customers will look at using standard SSDs in non-production, so dev test environments, just to save cost. It's one of those things, we've changed our position because originally we did all our validation using premium SSD, and the kind of corporate engineers said, well, you should really focus on premium SSD. We know that works. But again, standard SSD is roughly, I think I'm right in saying, it's either 50% or 25% of the cost of a premium SSD. And if you've got a dev system which has got, a dozen users doing development, you really need the performance of premium SSD, and the answer is probably not. So again, getting the right disk for the right purpose. Don't think you need to go Ultra because it's a big database. We can do splendid things with multiple premium SSDs. We've also introduced some new features. So things like disk I/O bursting. So I'm trying to remember what disk. I think it's only up to the P20. It might be the P30. We support this, and it just allows those disks to handle more I/O. What it does is it's kind of credit-based system. So if you're for a period of time you're not really using all your I/O, you build credits, and then when something suddenly starts to generate a lot of I/O, you'll get more I/O from that disk than strictly its specification says you should get. Incremental snapshots, and you can start to use those as a backup solution. Either script your own, kind of roll your own scripted solution, or if you work with a product like Combot as backup product, it will actually now use snapshots and incremental snapshots. So you can take an application consistent snapshot backup of a running SAP database, so Oracle, SQL, DB2, etc., and HANA, and then use that as actually the source for your backups. Azure Shared Disks is another new technology. It's only been around for a few months, and we're starting to build that into some of our SAP solutions. So again, something people have had on-prem, but not in Azure. I'm going to skip over that. Quick example of something which, again, is a gotcha that people don't always realize. So just using premium disks as an example, each disk has a capacity, a number of IOPS, and a throughput. So I've got a database and I say I want 60,000 IOPS, and I can look at this, and actually the sweet spot you'll see is this one, the P30, because the ratio of IOPS to capacity is the best of any disk we do. So I could get 65 IOPS by just adding 12 P30s. So that's great. So I look at my VMs and I say, well, 12 disks, I could actually do it on an E8, but an E16, that's great. 32 disks, use 12 of them for the database data disks. I need some for log. I need an operating system disk. somewhere to install the executables, etc., still probably only be at 16 to 18 disk drives. But be careful. Look at that line that says maxed IOPS, which is only 32,000. So yes, an E16 could support enough disks, but when you're looking at disk performance in connection with a virtual machine, you have to make sure the VM itself can also support the IOPS you're trying to deliver. So in reality, for that sort of use case, you would be looking at either an E32, which is going to give you 64,000 IOPS, which is probably going to be enough. Or we also have these things, which again, you may or may not have noticed, these things we call core constrained virtual machines. So an E32-16 effectively has the memory and all the other characteristics of an E32 virtual machine, but only has 16 virtual CPUs. So as most databases are licensed by the virtual CPU, you get the extra memory, the extra IOPS, the extra network bandwidth, but you've only got 16 virtual CPU that need to be licensed. So it's again one which people tended to miss in the early days, but you've got to match the two. There's no point in just throwing a lot of storage at a small virtual machine and thinking you'll get the IOPS or the throughput you're looking for. So be careful. I'm assuming no questions at the moment. Availability, always a hot topic. SAP is often business critical, if not mission critical. In particular areas like manufacturing, it's not uncommon to find out if SAP is down, your manufacturing has to stop. We've seen that in everything from sort of pharmaceuticals to, in fact, recently was a large alcoholic beverages company, because they use SAP to track everything. So products produced, barcodes are stuck on boxes, and that is all traceable through SAP. So SAP down, it can't do any of that. So we have a standard kind of reference architecture for SAP running in Azure. If you're not familiar with the full details, we've got our database servers down the bottom here. We make those highly available. I'll come back to this in a bit more detail. We've got our application tier at the top here. There's kind of a nuance of a primary and an additional application server. And then there's this extra little bit that SAP has, which is referred to as essential services. It's a couple of processes which are critical to the functioning of SAP, and they need to be protected because they're a single point of failure. The app tier, if you lose an app server, any user connected to the app server loses their session, but can immediately log on to one of the other application servers. These two, the essential services, need some shared file systems. So the original reference architecture, we had to create a kind of an NFS, highly available NFS service using another couple of virtual machines. And it's to a lot of on-prem customers, this starts to look a little bit messy. Now, I've got the right slide in. I'm going to skip that one, actually. So the first thing we've been working on, and we hope to release shortly, probably in January now next year, is getting rid of those virtual machines providing the highly available NFS service and moving to use Azure Premium Files NFS. So Azure Premium Files NFS was introduced earlier this year. It's an NFS 4.1 compliant service. It's just a native Azure service. You consume it as a service. No VMs to maintain, no operating systems to install and maintain and configure. And the bits which we've been kind of working on for SAP is building things like the zone redundancy so that these two VMs can be reading and writing effectively to the NFS share. So if the primary of this central service go over fails, it will fail over to the other node and it will just pick up the premium files seamlessly. So that's been taking some additional work and testing and validation of some various things we've had to do to make that all work. But that is coming, as I say, Q1 next year. We had an update this afternoon just to say we've been doing a lot of testing. We've had some problems with the actual software installation process from SAP not working properly with Azure Premium Files NFS, but that's now all but fixed, and we're just doing the final validation and testing.
Okay.
So that kind of, Oh,
Nick, it's good. Sorry, we've got a couple of questions. A question from earlier. What's the name of the tool set to switch the SAP operating system and database?
So it used to be known as R3 load. And it actually is it runs both an export and import routine. It's now part of what's called the Software Provisioning Manager, or SWPM for short. But it's a standard utility which will just export all the data and then import it all again.
Brilliant. And the question, the most recent question: any reason not to use Azure NetApp Files NFS as it's been around longer?
No, there isn't. It is supported. Right now, it's one of those funny things. It's been around longer, but what we've seen is a lot of our customers are looking to use availability zones for high availability, and quite bizarrely, we will have full zone support for Azure Premium Files NFS sooner than we'll have ANF with proper zone support. So there's two things on the ANF front. We have to have ANF obviously in more than one zone to do zone support, and the kind of synchronous replication and making the data available simultaneously is something that they are working on, the same as we've had to work on making it all work with Azure Premium Files. So that's expected either late Q1 or in Q2 of next year. We'll be at the option of ANF. Some people love ANF. Right now, it's supported for that use case. It's also supported for the HANA database, but it's not currently supported for any other use cases around SAP, though engineering are working on support for Oracle databases using Azure NFS, Azure NetApp Files. One of the reasons we haven't supported any other database currently is right now ANF does not support proximity placement groups. And again, if we're going to provision a virtual machine to run a database and put the data files onto ANF, we need to know they're in the same data center. For the HANA workloads, what we do is we do manual pinning, which is basically you have to raise a support ticket and engineers have to beaver around in the back end of Azure to make sure things are co-located. That's not scalable as a technical model. So NetApp are working on support for proximity placement groups, and at that point we'll start to release support for other database files going onto ANF. But that's something they're working on. I think Azure Premium Files NFS, if I look back to when we started work with NetApp probably 2.5 years ago, Azure Files was lacking in a lot of capabilities. What's been happening in the meantime is we're adding a lot of features to Azure Files and making it a much better native service. And generally speaking, it's just cheaper than ANF, and it's more flexible. With ANF, there's a minimum pool size you have to have, and depending on what you're deploying, that can be a lot bigger than you really need. So ANF will continue to be supported, but it's an option. So here's the things you can't do. And this, again, a lot of people historically still run traditional sort of shared clustered environments in where you have a shared disk storage. So you have effectively an active and a passive node, and that could be a physical server or a virtual server, and shared disk storage. If the primary database server fails, then the disk will be picked up by the failover node, mounted on here, and the database will be restarted. Though we now support shared disks in Azure as of a few months ago, right now there is no support for using them for databases to support SAP. That could change, but it's not in any immediate engineering roadmap. So what you have to do in Azure is move to what I would call a more modern way of doing database HA anyway, and that's where you have two virtual machines running the database and you use synchronous replication. And this is really how most modern databases protect themselves, is having the instances kind of replicated effectively, in memory, in real time. And the benefit of this is if I fail over these disks and restart the database, I've got I'm probably looking at several minutes to fail over this database and bring it online, because this will be When this thing fails, I've got a crash consistent database here. I've got to mount the disks. I've got to start the database. I've got to recover the database. Now I can start processing workload. Here, these two are kind of in sync. We can fail in a matter of seconds, to the point that very often the application server doesn't even see the failover happen. Here, normally, you can tweak timeouts and things to try and keep the application servers active. They'll just keep retrying. I say you're going to be into a few minutes to restart the service. And so you can set timeouts just to make this thing retry for 3 or 4 minutes. What generally happens then is the user just logs out anyway and tries logging back in again because they assume the system has died on them. So we have to change this. And the other thing is what people do is they stack things together. So in my architecture, we had this thing called the central services. We want some shared file systems. Particularly in the Unix world, you could do all this on just a pair of physical or virtual servers. Again, when we get to Azure, we have to split these things up. Your databases become too active, well, a primary and a standby database, both running synchronously replicated. We split out the central services. If we need an NFS cluster, we have to split that out as well. So fundamentally, this architecture doesn't work, so it's a re-architect. But going back to, whilst I was slightly kind of negative about HANA, when you move to HANA, this is what you'll do anyway. HANA won't be just 2 to 3 minutes to do a sort of traditional failover. You can do it because it has to reload memory. The bigger the memory, the bigger the database size, the longer it takes to reload. You're probably looking at about 10 minutes per terabyte to reload. So if you take a 12 terabyte virtual machine, it'll have 6 terabytes of data. That's an hour just to reload the data. That's how long your cluster would take to fail over. So in the HANA world, you do this anyway. So this is really the way modern database, if you want fast failover, have been going. And we even have, a stage further is these people who run the whole thing. So the app tier is also down here. And again, we have to split all this out. So what we really have is a consistent architecture in Azure. It's just for people who've got older, particularly Unix systems, where the architecture has been probably around for 10 or 15 years. It's not unusual to find these different scenarios. I'm sure we're conscious of time, so very quickly, Azure Backup currently supports HANA as a streaming backup, and SQL Server is effectively more of a snapshot-based backup. The Azure Backup team are working on 2 things. They're moving and will provide, again, I think Q1 next year, based HANA backup, and it will be an application consistent backup, but based on using Azure snapshots behind the scenes. Once that is released, they're going to start working on delivering the same capability for Oracle, and then DB2, and ultimately probably SAP's own ASE, which is the old Sybase database. And we expect those to all become available during 2021. So we'll get proper Azure Backup support. You can do stuff today. You can script it yourself. It's just it doesn't work out of the box. This will be straight out the box working. So, as I say, by the end of 2021, we should have all the key databases fully supported by Azure Backup, which is great news. And finally, just a couple of points. Automation. I know you me to mention at the beginning of this call. I would say we haven't been the fastest company on the planet to really build automation for SAP. We are rectifying that. There's been a project running for most of this year. What we're actually doing is, and it should be updated before Christmas, there is already a GitHub repository for the beginnings of this. There should be a major update before the end of the year. What we're really doing is we're producing a set of Terraform and Ansible resources which will allow you to build the infrastructure and configure the infrastructure for SAP. The idea is SAP has so many subtly different applications, slightly different requirements. To actually build a 100% complete, fully automated deployment solution for every SAP requirement is virtually impossible. So what we're doing is creating a set of reusable building blocks. There will be standard assemblies, which you can just use out the box. So, for example, if you want to create a clustered central services across 2 VMs using either SUSE or Red Hat or even Windows, it will go and build the VMs for you and configure them and configure pacemaker clustering and all that stuff straight out of the box. But if you've got some other requirement, which is slightly different, where you want to build the cluster, the idea is those will be very modular. You can take them, you can tweak the Terraform, or you can tweak the Ansible playbook to do whatever you want. And we've also got 2 or 3 partners already working with us on some of this. And the idea is that partners can take these building blocks. And the hope is it will become a community project. So it won't be something, a truly 100% fit, out of the box, delivered by Microsoft. It'll be, the usual 80-20 rule, 80% of what you need there, out the box. You can consume that straight away. If you've got particular things you want to do, take it, modify it, and hopefully ultimately people will push back into GitHub extensions and add-ons and additional capabilities, which they've built and which they think the rest of the world will want to use. And that's the way we want to go. We want to open source all this. We don't want a kind of black box, closed source solution. We want something that the community can build on and really grow. And so we want to kind of encourage partners as well if they're working with. So what we found was some partners are doing this. They tended to do it as a closed source model. But if you're a customer, you actually want to be able to own that stuff, because you want a situation where 3 years down track, you want to get rid of the partner who's been looking after your SAP estate in Azure, and kind of like all that automation tooling disappears with the partner. You want something you can also own and have control of going forward. Hence the direction. And a bit of a plug. It's getting a bit out of date now. This book was published it's supposedly in November 19. It didn't actually get publicly announced really until January 2020. It is already a year out of date, so there's stuff in here which isn't up to date. Personally, I'd love it if you purchased the copy, because I might one day get some royalties on it. But there is, importantly, a free download of this. It goes into a lot more detail on all the stuff you might ever want to know about deploying SAP on Azure. To quite a degree of technical detail, it doesn't take you through the row by row, line by line steps to do stuff, because virtually all of that is available on docs.microsoft.com. The idea is it sits somewhere between the marketing and that, line by line, command line sort of set of steps to run, and kind of gives you the contacts and the thought process and what you need to think about before you try deploying SAP into Azure. And I wrote it with Bartosz, who's one of our UK SAP CSAs, who some of you may come across